How's it going, everybody? Welcome to another live stream repair. We've got, yes, the usual HomePod. We'll go ahead and knock that out first. It's got the oh so common no power issue. And then we've also got a couple of amplifiers to take a look at. Also for the HomePod. And after that, we'll move on to the interesting stuff. We were sent in a couple of LG 5K monitor mainboards, and they need new USB-C ports. This is a pretty common issue with them. Sorry if I was speaking slow, I was pulling up the emails. Anyways, it's a common issue with these 5K LG monitors for the USB-C port to get loose, especially when it's the power cable for it. So we've got two of these in today to take care of, and the person that sent this in was Justin. They're actually an eBay seller, iPhones Plus, and they also happen to sell replacement USB-C ports. Both actually. They've got I believe the standard version, and then they also have an extended version of this port. And I had actually previously bought a couple of these ports from iPhones Plus on eBay a few months ago, because somebody had said that they were going to send their LG 5K in for me to do the USB-C port replacement. And it never happened. I ordered the part, but they never sent it in, presumably because they couldn't find a way to cheaply ship a whole monitor to us. But iPhones Plus here, or Justin, does get their hands directly on the parts that need the work, and they have the parts to do the work too. So they sent all of that in for us. Really appreciate that. Makes it a whole lot easier for us. But if you're looking for those USB-C ports to do this yourself, definitely go head over there, because I bought these from them, and then here we are now. They're having us fix a couple of those boards. It should be a complete walk in the park compared to the Steam Deck USB-C port replacement that we did a couple of weeks ago. That was a little made me a little nervous, because there were some really sensitive chips right next to it. In particular, I believe it was like either the NAND chips or like VRAM or something like that. But basically kind of a pain. But didn't have any problems, just covering them up in a little bit of tape and just taking it easy. And sure enough, we didn't have a problem. That was pretty fun. Oh yeah, of course. Almost forgot to mention, I just finished 3D printing this HomePod top basket. Here's what the original looks like, and here's the 3D print. I'll probably end up taking this and modifying it a little bit and making my own version of this model. But what's really crazy is that it works. Everything fits. Joke's on me. If I knew how to put it together. There we go. The screw holes line up, the screws go in. Now, the only problem I can see is the the mesh might look a little funny. This seems to sit a little higher up on here. See that? So I might try to tweak this model a little bit and make it better. However, for my testing and purposes for this, this is color changing thermal PLA. So as it warms up, it goes from this deep purple to a pink to a translucent, and you can start to see the infill pattern as we warm it up here. I think that's pretty neat. So the idea is I'm gonna take my HomePod that I don't have any mesh on, replace its top basket with one of these, just keep the mesh off of it, and then we can see it change color as we use it and as it warms up. I think that's pretty cool. Also, funny enough, it not only fits right around the rubber base of this, so if you're working on your own HomePods, you've got a nice stable surface for it that you can pull your mesh down without it creasing against the table. And not just that it fits, but it fits better than what we have been using since we've started this. So that's what we're going to start using. If you want to print this yourself, I've got a link in the description. Anyways, let's go ahead and get started on Nick's HomePod here. I believe it's got no power, so we're going to go ahead and knock this out, and then we're going to take a look at a couple of amplifier boards, and then we'll knock out those LG 5K mainboards. Anyways, checking our symptoms here for this HomePod. We've got nothing happening here. We've got about 3 watts of power draw from the wall. That appears to be a dead diode. Much like many here that come in for no power. It's usually the same diode on the amplifier board inside. Just like this one too. And look at that. The person who sent this in even knows what's going on. They've got 1748K there on that piece of tape under no power. And that is pretty much spot on what is happening. So, taking a quick sneak peek. Here is our Schottky diode. The amplifier isn't the power supply necessarily, but the logic board does get its power from the amplifier. So if the amplifier craps out, then logic board and display won't work either. Anyways, this diode in particular is what loves to fail and cause no power in these HomePods for seemingly no other reason than a bad batch of them floating around, and that 1748K refers to the date code, the date that that diode was manufactured. So we have seen over the years of working on these thousands of these diodes in these HomePods, and the one thing that remains consistent is the ones that fail within date code 1746K and 1748K. So there was like a 2-week batch of these diodes that are just popping left and right. And then hundreds of other examples of these diodes in these HomePods, much older and much newer, working just fine still. We continue to only see those date codes failing. So chances are that's what's going to be inside here. Oh, also, and if you don't have your own 3D printer, I will be designing my own one of these. I don't know if the person who designed this is cool with me printing and selling it and making a profit off that, but if you don't have a printer, keep an eye out soon and I'll be selling 3D printed replacement top baskets that will, you can get like color changing filament, and if you don't want to do the naked look, you don't want to do color changing, you just need a replacement top basket. It'll be way cheaper than, where did it go? The original replacements. So, yeah, here is that basket that we are talking about. And if you imagine, you can just take this mesh off and run the HomePod without any mesh on it at all. It's perfectly fine. And you've got this on the top that changes color. I think that'd be pretty sick. Oh, and that even works better too. That's just great. I love it. This is wonderful. Let's get you behaving again. Sometimes the sock on the inside likes to bunch up. And give you this weird, like, lumpy effect. So I just wanted to fix that up. But what you can do if that happens with you, what's happening is this mesh is actually two layers. You've got the fabric on the outside, and then you've got this like sock on the inside. And they are two different movable layers. They're only attached at the top and bottom seams. And what can happen is if you're moving this up and down, that inner sock can bunch up. And all you need to do is pull this up, and then you can peel this back and just kind of pull that sock up. subwoofer smells great. Just making sure. We don't want a stinky subwoofer going back in there after doing all this work. There you have it, another one with 1748K on it. Let's do the dirty. a sec for that. Is it hot yet? No. Yeah. Nice. And here's the magic. knife there.
I'm having trouble connecting to the internet.
Screw it. We'll give it new filters. It's like it looks just bad enough. It's like just barely not bad enough, which is bad enough for me. It's the, if we didn't replace these filters, that would be the equivalent of giving your roommate's car back with, like an eighth of the tank of gas left. And you took it when it had 3/4 of the tank. Well, they didn't. To be clear, these weren't 3/4 of the way still good when we got this. I just thought that was funny. It totally hasn't happened to me before. These, here they are. We can get them. We're gonna chuck them. Told you I'd chuck them. I thought I saw something in there. Nothing's missing on our board. I wonder if it just got picked up onto my tip from the my little brochure, my little guy here. I forget what the little scraper's called. That's how it's done. Take notes, folks. They're nice and straight, perfectly parallel with each other, perfectly on their paths, not crooked, not overheated or overworked. That's going to give us a good long-term, long-lasting result. Especially when we're talking about filters that are supposed to remove DC in the order of less than 50 millivolts. No more than that should be going out. So when we've got 46 and it continues to keep growing, it's just barely too close enough for me to say, yeah, good enough. Because that doesn't get better. It never gets better. It always just gets worse. And as it gets worse, that DC voltage gets bigger and bigger. And it's going to start damaging parts that aren't supposed to see DC voltage. Especially when it goes through the amplifier, which is going to amplify that DC voltage. The filters are supposed to remove that. The amplifier's job is to amplify what you give it. So if you're giving it garbage in, garbage out, that's how you eventually get death farts and blown up bass speakers. Alright, that is a lot better. So of course it's probably gonna grow a little bit. It's gonna fluctuate, and it does take a day or two for capacitors to fully settle back in once you've put them through the heat that it takes to solder them to your boards. That said, we can see that we've already got a great improvement. We're holding pretty steady at about only 7 millivolts. So that is beautiful. Haven't gotten to try something yet. I want to try it. Oh, I see what they did. Okay. Okay. I see you. It looks great. everything lined up. Wow. That's impressive. We'll go ahead and put this on if we have time after the end of the stream. I've got a HomePod just for it. moment of truth.
I'm having trouble connecting. I'm having...
Beautiful. Nick is fixed. Oh boy, oh boy, oh boy. It is time. Oh boy, okay, that one is definitely loose. I need my USB-C cable. I need my USPA. Oh. USPA. Yeah, we don't need to try that one, but this one honestly. That one doesn't seem loose. Yeah, this doesn't seem loose to me. Yeah, they all seem about as solid as the next one. At least on this one. This one, it's very obvious. But this one seems fine. Well, we'll go ahead and replace it. Either way. And the purpose of these extended ports, I'm just taking a whack. But these extended ports are longer than the originals. So if we look at the back of an LG Ultrafine 5K, what we've got are USB-C ports, including, I believe, yep, there you go. So there's your main one. And I believe that's the one that most people use. Well, this doesn't look like the same. Is it? Okay. Anyways, it looks very similar at least. So the problem is, I'm just taking a guess. You see how the USB-C port doesn't stick all the way out of the plastic? So what happens is, with the cable plugged into the port, lets the port wiggle around and break loose off the board over time. So you get the extended port, and now the housing of the port sits a little bit outside of this plastic, or at the very least flush with it, so that way most of the stress should be relieved by the plastic housing of the monitor instead of the freaking port that's so stupid. I mean, the extended port is absolutely genius. I have no idea who came about that kind of a fix and how, but good job. Let's give it a go. First, this is the first time that I've done this sort of thing, but if this goes well, I will be more than happy to offer the same kind of service. If you have the board itself already taken apart, you just don't feel comfortable doing the USB-C port, we'll do that for you for $40, at least in the current times pricing. Don't email me after watching this video has been published 5 years later expecting the same price, but if you for some reason are able to and want to send in the entire monitor assembled, we'll talk about that. Usually how my rates work is I charge X amount for the entire device pre-assembled if you need me to take it apart for you, or I charge 50% of the normal repair if you've taken it apart, you've diagnosed the problem, and you just don't feel comfortable with the board repair itself and you send that part in. So I think it is a pretty wicked model, and let's knock this USB-C port out. First things first, we're going to do a quick inspection, as I was saying before we went off on whatever we were talking about. This is my first time working on these, so we need to be sure that we cover all our bases and make sure there isn't anything that we need to be watching out for. Wow, this is going to be just ridiculously easy, huh? I mean, as far as and the problem that they were saying they were having with one of their other guys that were working on these beforehand was that they kept melting these connectors. So I imagine we can easily work around that. First of all, we won't be a doofus. Second of all, where's my tape? We've got some capped on tape here to cover things that don't need to be exposed to heat up as much as possible. And of course, the less of the board that's exposed to that heat, the less that's going to transfer through to our plastic ports on the back, so even if there isn't anything immediately around this port that we're worried about damaging or melting, this can serve us a little bit of use if apparently people are having problems melting these ports on the back side when we're doing this job. So our first time at least, this is how we're going to do it. If this kind of repair ends up taking off for us too, then I may end up buying myself one of these monitors so that we can have a way to test the work after we're done, other than looking at it and going, yeah, I think that's aight. I'm not sure if you can just plug these in and see if they light up. No, because they don't get their power from the Thunderbolt port. They get their power from an external power supply, I believe. Yeah, it looks like they would connect through that. Most likely. Anyways, let's quit putting this off. Let's think of the best angle of attack here. So, as we're blowing our air down, we're going to be holding the gun like this. Just like this. So we want to think that our air, is going to be hitting our port, but it's also going to be hitting the rest of this, it's going to be going this direction and heating up everything behind its path. So if we look behind our board where that would be, we want to try to put that path where it's not going to hit anything else and give us a problem melting something. So it looks like this is going to be our best bet, just like that. And of course, actually, to make this also a little easier for us, let's go ahead and get some flux on there. This is, from what I've seen, going to be a relatively easy job for this particular issue, because it seems pretty common for people to either try this or just and damage things, or just by use rip the port out and rip a whole bunch of traces off the board. I'm glad we're not doing any traces, but let's get it done first before we put our work on another episode of Northridge Fix. Alright, here goes nothing. That's how you do it, folks. Oh yeah. They're a little warm, but I can touch them. And if we get super up close there, sorry I forgot to switch to this camera, but we can see we've got every pad still there. Are these through hole? No. That's part of the problem. These USB-C ports, they're... Oh, actually, they do look a little through hole. Yeah, okay. Yeah, they are. Oh, I'm silly. Alright. I was gonna say that would be part of a problem is if they're not through hole, they're just straight up SMDs purely. That would be completely stupid for a port that's put under constant stress. But then again, we're still in this situation anyways. Forgive me, I need to use my eyeballs for this. I will get an HDMI microscope soon, I promise. Maybe shoot me a chunk of change. I've got my PayPal and Cash App up on my website at the very bottom, nextfix.com, and I can get ourselves a nice microscope sometime soon. Okay, so we've got those pads almost tipped up. Hold on. And here's the trick. For your mounting, for your big ground pins, use some low melt solder first, just to get it on there, nice and easy. And then go back once you got the port on there and double down with the full strength solder. You don't want to use the low melt stuff on the pins because the pure low melt's a little more brittle than the pure stuff, regular melt stuff. But for the pins that you can reach, and in this case, unfortunately, it's only our big mounting ground pins. Make it easy on yourself. Use some low melt solder to get it on there. Alright, these look very pretty. What we want to do is prep this too also with a little bit of solder. I'm going to want to turn my gun down a little bit, or my soldering iron here. So we don't melt our connector. We are ready for mounting. We're gonna get that nice and hot first, nice and melted. Alright, a little trickier than I thought. Let's try a different angle here. Okay. My copper braid has completely disappeared. Where did it go? I need that stuff. I found it. So good news is we're not having any problems not melting the connectors back here. Bad news is we're just having a little difficulty getting the thing on there. But you know us, we take it slow, we take it careful. We'd rather we take our time and get it right the first time than break shit. Let's see. Oh god, they're awake. Oh god, they're awake. Give me 1 second, I'll be right back. Hello. I have a snack. The wife and kid are awake. So we gotta wrap this up. And we will have to pick it up later. I did just realize we were using the regular port, not the extended ones. So. Okay. Here's the plan. Because, truth be told, this is not quite as easy as I was expecting. It's still not difficult. I mean, like, I was kind of worried about melting the fan connectors on the other side of the board here, but so far it looks like we haven't done anything to them yet. They're just fine. So I wonder if that fellow is. Oh, that would make sense. Maybe he's heating up the back side of the board. Okay. I'm trying to wake up the rest of this solder in the. Anyways, here's the plan. I'm gonna finish practicing with our regular length port here, because we've only got 2 of these extended ports, which is the ones that they wanted us to use for these boards. But I am practicing a little bit here, and as you can see, the port is starting to see a little bit of heat. This side is still perfectly fine, but we want to make this nice and pretty for them. So let's try cleaning up and getting the short one on there one more time, and then we will get the extended version of that port actually installed. So, I am tempted to, because the problem that I keep seeing here, and it's a good thing that we're practicing with the short ones first, because I don't really care about the short ones. It seems like people are going to want to prefer the extended ports to prevent the problem happening again. Anyways, we're practicing with the short ones because I want to try to find the best way to get this port on here without damaging it. And we have melted it a little bit, so I don't think we're going to be able to get away with heating it directly on. We're probably going to have to do what we do with our amplifier boards with a similar connector and heat it up from the bottom of the board. And the problem with that is you've got your plastic fan connectors here, and that is probably what other people are doing, and that's probably why people melt these connectors. I was assuming people were melting these connectors on the back of the board here because they were using too much heat on this side, and it makes sense that that wouldn't be the case now that I think about it. So the best course of action would then be for us to remove these fan connectors, because they're only 4 pins each. That's trivial to remove for the sake of making sure we don't melt them, so that we can get our connector heated up and in place from the bottom of the board. Because the problem that I keep having here is getting it through all 4 holes nice and straight. And with the hot air blowing on it at the same time, it's hard to get it lined up. So the best course of action for this kind of stuff is, of course, hitting the board with heat from the bottom and getting that solder on top hot enough to melt indirectly. That said, though, I do not have any more time right this moment to do that. We will have to come back to this in a few hours. But later tonight, we will be back. We will remove our connectors back here and try that old trick. And if we can get that reliably using one of these spare short connectors, then we'll try with the real deal using one of the extended ports. Alright, we didn't get it done yet, but go ahead and leave you guys with the suspense. I'm gonna go eat some dinner, hang out with the wife and kid for a little bit, and then when kiddo falls back asleep, then we'll be back to work on this later tonight. I'll catch you guys soon.